Okay, hi, I'm Dave Israel, so I'm from the NASA Goddard Space Flight Center. And as Don mentioned, I'm the principal investigator for that LaserCom relay. But now I'm also the architect for our division at Goddard that does the exploration and space communications projects division. So first, just on the title with the near Earth. So for most of the universe, Pluto is near Earth, right? But within NASA and our space part, when we say near Earth, it's really within 2 million kilometers from the Earth. So in context, it's seconds of delay, maybe up to 10 seconds worth of delay. So I'm going to talk about how there's been another round of studies about what the near Earth communications architecture should be. So I'll be discussing some of those results and helping to make the case for how DTN fits in. Okay, so if I get the next slide. So last year when we were together, I gave the extended version of this discussion of the success of the DTN demo over LLCD. So this demonstration was DTN over the LaserCom links. We didn't fly any DTN software at all on board. It was really once again demonstrating, improving the concept about the magic of the protocol layer stack. I told Don once the link was working, if he would just let me get access to where the bits come in and out of, then I could do this DTN demonstration, and we did it, and it worked as as it should have. So it was a very beneficial demonstration, but the part that DTN worked was sort of what was expected. We were just able to really see that it helped with over the LaserCom links. And Don showed that chart on the lower right you saw, which is probably the one that best demonstrated that the bundles that were lost during that 2 minutes of cloud outage made it through. But there were some other benefits that came from that experiment. So the first one was that we tried to operate this system and implement it, and it wasn't the usual the usual gathering of the DTN enthusiasts and developers. We were working with the team that was flying LLCD and getting them to use it and get it all implemented and getting this insight. And we saw that there were certain aspects of it that we got it configured and operating, but it was not, it wasn't like straight out of the box that you could implement it and get it running. And then also just being able to sit at a control center and watch the bundles flow and sort of manage that network and see how it was operating was not so straightforward. So there has been a lot of work in the past year and continues to be in this sort of deployment. How do you configure a node? How do you configure the networks? Once you have the nodes and the network operating, how do you actually monitor it and make sure that it's working? And if the bundles aren't getting where they're supposed to go, how do you give somebody the insight so that a person can call up and say, hey, my bundles didn't make it, where are they, right? Another great benefit was really this mutual visibility. I've sort of found myself in the middle of it between the optical communications world and the LaserCom folks, and then the networking and the DTN crowd. So we get this visibility. We've sort of given the same talk to the optical communications world and to the networking folks, and of course both sides see networking benefits optical comm, and the other side sees optical comm is of great benefit to networking, and that's just the way it goes. All right. Okay, if we can go to the next slide. Okay, so Don referred to this, and this I think is a very important point. In the near Earth environment, like I said, there's only seconds worth of delays, but we have delay tolerant users, and so that's really a key to helping to make the case and to be able to build out your infrastructure and your architecture, is that even though you could have a system where all the data could make it just the speed of light time to get to that scientist. The thing is, the scientist is at home sleeping, and maybe it'll show up the next day or some other point, and as long as the data shows up, it's fine. So we just flip pictures. So I took this as an opportunity to once again show the 25th anniversary official photo from Hubble. So that picture, that's distance that's 20,000 light years away. So what's another day or two of delay to to get the data? And actually, it's lots of data that they accumulate together and they process. So it's not like a quick snapshot that somebody has that they want to send back home and call somebody up and say, hey, did you see that picture? Right? You can have a delay in the system that's beyond the speed of light kind of time. So if we go click the next bullet. So and this is something that the real-time interactions are possible. So Hubble Space Telescope is a TDRSS user. So it's in low Earth orbit. It communicates through the geostationary TDRSS, and they can get their links and they can do real-time commands and telemetry and see how it's doing. But then it also has stored data, and then periodically it'll just play back and get all that stored data down. So you do have that opportunity that when the link is there, it's bidirectional, it's completely end-to-end, and it's low latency. If you click to the next point. So really what's driving the latency requirements are, in most cases, it's just the onboard storage that the spacecraft has. They have like enough storage for 3 hours worth of data accumulation or something like that, and they just need enough link time to get the data off before they start to overrun their storage. So really, and in some missions, they prefer to operate that way. Even if you gave them a full-time link, they wouldn't want it because in some cases they have to stop their science in order to reorient their spacecraft to do the comm link or to shut things off. And in other cases, maybe it's just a power budget issue, so they don't want to have their transmitter on all the time. So there's really benefits to the user as well to be able to just kind of store up the data and then transmit it. So let's say if we click the next one. So the bottom line is that if you're the network provider, it's not necessarily a bad thing if your system introduces these delays. It could be completely acceptable as long as that end user gets their data at the time that you guarantee it by the end of the day. Something else to point out, so if the requirement is really for the user to get the data off of their platform because of the memory issue, then that means that you don't have to get the data all the way to the endpoint. You just need to get it off of their spacecraft. So that gives you more flexibility to just be able to store and take that stored data and put it one hop down down the line. You don't have to guarantee that you get it all the way to the end destination. Okay, next chart. Okay, so here's first a picture of like a near-Earth architecture where we have the user platform talking through a relay, so that would be like a TDRSS in today's setup, to the ground station, and then all the way to the right, that's the Mission Operations Center or the Science Operations Center. And all those nodes get a benefit from DTN, like we saw in the demonstration, where you can have routing, you can multiplex different types of data together, quality of service, reliable data delivery, and then the data storage management. It can kind of help people, instead of having to keep track of files and some of their memory usage, you get some data storage benefits. But if you can click. So over at the user platform side, you get some additional benefits, and that's this rate matching between the onboard system. So let's say that you have an instrument that's generating data at 10 megabits per second or 100 megabits per second. But then your link is a gigabit per second or the 200 gigabits per second. You get that built-in rate management sort of built on top of it. So that's the buffer and burst that Don was referring to. Okay, click again. Okay, so at the relay and at the ground station then, you have that same rate matching benefit. So especially if you're doing storage on board the relay, maybe that user has the 1 gigabit per second link up to the relay, but the relay has the 200 gigabit per second link down to the ground. So you can store up a bunch of user data and then blast it down. And then the network layer also gives you that benefit of having some RF links and some optical links, and there are different data rates. So you can use the network layer just to kind of bridge your data across those different types of links. Okay, click. So then at the MOC, you also have the ability to transmit and receive your data across multiple paths. So this could be you have multiple ground stations, and some of the data comes in through different ground stations, or we're hoping in the future you have maybe some NASA-provided ground stations and relays, and then some commercial ground stations and relays. And if you're doing everything at a network layer at the bundle, then it will make it easier to just kind of accumulate the data as it comes in through all these different paths, or to send it out. So go to the next click. So if you're going straight to the ground station, so this is again common, people going direct to Earth, and this is or even now with CubeSats, people going directly to some amateur radio operator's backyard. They just dump the data down to the ground station, and DTN would just give the information for the data to show up and be able to be routed back to its destination. And then in the case of click one more time, so the case that Don was referring to, if your rate is high enough and you had enough memory, then the scientist could just have a telescope on the roof of his building, and if it was guaranteed, or that worked out that at least once a day or once a week or whatever the case may be, that where they live it's going to be clear enough, spacecraft goes overhead, just blast all the data straight down, to his rooftop. Okay. Okay. So we just completed and we're out briefing a recent study, and one of the things that came out of it was this concept of the space mobile network, and so to kind of get through the the concept of it, if you can just click. Okay, so here's the analogy I'd like to use. So let's take a breath and just stay with me here. Okay, all right. So we're going to the Space Mobile Network bar and grill, and it's a beautiful place. Walk into the bar. There's enough seats for everybody. We got BB King on the jukebox this week, right? And so everybody goes, and when you go to the bar, you can get a beer, you can get drinks, maybe you can get a little bit of food, but you immediately can get that level of service there, all right? But some people are hungry, some people will be happy to just stay at the bar all night, and that's fine. So some people are going to want food. So then you ask the bartender, can we get food? And he'll look and see if there's an available table, and say there's 4 tables there, and 3 of them are occupied, and he'll say, okay, there's 1 table there, and the rest of the people have to wait. So this goes back to the idea of the delay-tolerant users, right? So the users are willing to wait, and then you can have fewer tables because the users are waiting, and then when the tables are available, then they can go and have the meal, right? So then this gives you this. So this is kind of the architectural idea that you see, in place all the time, so that you can build out the infrastructure. If you have too many tables, then you're paying. And you're the operator, then you're paying a lot of infrastructure overhead and the costs to put all those tables in place. If you have too few tables, then you have the problem that you're not able to meet everybody's requirements. But you have this option to start smaller. As business picks up, you can add tables. Or if it turns out that more people just want to drink beer than eat your food, then do away with the tables and just add another bar, right? Okay. So if you keep this in mind, then if we go to the next chart, so now back to the regularly scheduled NASA briefing. So the idea with the Space Mobile Network is is that you have these links, the multiple access links, which are those links that are always available. So this is going into the bar. So the bar is always available. You can get that basic level of service right away. There's no latency, there's no wait, and there's a certain amount that you can get. And then there's a limited number of the single access links, which is, in my analogy, it's the tables, right? So if you have enough tables to be able to meet everybody's requirements, then all your customers leave happy, but you've got sort of that minimum infrastructure that you need in order to meet those requirements. And then it gives you this path to evolve and build out the infrastructure in pieces, as you can afford it, as you can see whether you've set up your restaurant in a beer drinking part of town, or whether people are going to want the meals. You can expand, and then something that doesn't usually happen, but in our architecture, the idea of sort of relationships where you could come in through one of these multiple access links and try and get service, but there's an agreement where you can get a table at, equivalent getting a table at the restaurant across the street, right? So this is through the multiple access link, you can request service, but then the response back to you would be that there's a commercial ground station. You'll be over a commercial ground station in 2 minutes. The system will be waiting for you. You can dump your data there, or there's another relay. You can set up the data that way. So then it gives this means for interoperability between agencies, between countries, between commercial providers and the government that way. Okay. So here's the artist concept picture that I guess things to note. So you do see that there's this mix of RF and optical. We are looking at technologies to use optical links even for the multiple access service, which would be a way to make it a lower burden on the user to have smaller terminals in order to be able to get that instantaneous connection. But there's a combination of commercial and government provider systems, combination of direct to Earth and through the relay. And the point I'm trying to get at with that bar and grill analogy is that so here's one artist concept version of what it looks like in 2040, but we don't have to have a plan to build out all these nodes and to do it now. If we have this basic infrastructure idea, you can start small and build it out. And again, with this idea that there are these delay tolerant users that are out there, then it I think eases kind of the cost of entry to get the architecture started. So on the point Vin earlier, when you were asking about, you're talking about the systems that we're looking to put 1,000 satellites in orbit to give internet access, to the whole, to everybody. Then to me that sounds like it's somebody that's just trying to build enough tables for everybody when they show up, right away, and which for like a commercial internet service provider, maybe that's sort of what you have to do, because everybody wants full end-to-end access all the time when they connect. But at least for our applications, there's kind of we're taking advantage of this assumption that at least in the beginning there's a significant percentage of the users that the delay is actually fine. And as time goes on, if the links are available and that they would like more links, then you have to put more nodes up there and more single access nodes and add more tables is this case. Okay, go to the next. All right, so I think Don really covered the list of essentially of the key remaining work in the DTN area. We do have, so Don emphasized there's the flight side of like the hardware for doing that storage and and data processing. There's a same problem with a slight variation on the ground side. And on the ground side, one of the things that I believe is not fully appreciated about like the ground stations and the ground systems is that on the flight side, you can build the system to work for that particular user, the user that that you're building the flight hardware for. And then once you've got it working, then you're set. Then you're done. It just keeps doing that for the life of the mission. When you're doing the ground infrastructure side, then you have to build that system to be able to support missions that haven't come around yet. So you need to have that flexibility to be able to be upgraded, to be reconfigured between passes to take the different types of missions. So so there are some different challenges to that network infrastructure side, even terrestrially, and there's maybe one level that's kind of like the enterprise terrestrial node, and then there's the access point kind of nodes. And I mentioned the network management and operations work that we're doing, but the big thing is really the experience part. It was huge. Just that little bit of time that we got on LLCD to get the experience. I know the ISS folks are seeing things and they're learning things as they go. And sometimes I worry that we're waiting until we think we have everything worked out 100% of the time. This is how it's going to be. Study it for 20 years and we'll get it right, and then implement it, and then we'll be done. And I guess what I'm really making the case for is to start building it out and learn as we go and evolve. Okay, so my conclusions. So we saw on the LLCD test, the benefits for optical comm, and hopefully the bar and grill thing made sense for how we could build up the infrastructure and work out in an evolved way to help for the delay tolerant user. And then if you'll indulge one more metaphor or analogy from me, I had my first Uber experience this past week when I was getting up at 5 in the morning to catch a plane to go to Korea. And so I get on my cell phone, I type in my home address, I'm going to the airport. It comes up and says, there were like different types of service you could get, and so you can get the car and it'll be there in 15 minutes. I was like, okay, that's great, I'll take the ride. So I'm in the ride to the airport, and I'm like, semi-conscious and still thinking because I was working on these charts, and I'm on the way to the airport, and then it hits me, it's like, oh, I'm the bundle. Now I get it. I am the bundle, right? So I realized that whole software, that whole thing that Uber is fine-tuning is this user-initiated service protocol, right? There's this real-time protocol that a user can get on. They talk to the provider on the other side, give the information to say, this is where I am, this is where I need to go. The provider comes back and says, well, you have these choices, you can be there in 15 minutes. You say, okay. Then you sit around and wait. When the time comes, then your ride's there and you go. So when we talk about maybe the challenges or protocols or things that people could be working on, to me that sounds like something that the CubeSat community and the amateur radio crowd doing it. Actually, when I thought of this, I wouldn't be surprised if somebody's already been working on this. Yeah. So I think that's my last analogy for the day. So we're working on the technologies. I do want to say that so I've been in a lot of these meetings, and actually the international meetings I was last week again about trying to build out the networking and the space internetworking, and I do think that the near-Earth applications are really not well understood and not promoted enough, and there's just too much of saying like, well, we'll wait until we're sending astronauts to Mars, or we'll wait until the lunar colony is being built, and then we'll need it. And actually, and so even like the name of this group, like the Interplanetary Networking Group, I think in some ways helps to kind of keep that idea going, that this is really for, you know, one day when there's human exploration to Mars, or it's something always in the future. And when you see, you know, with the limited resources, as the priorities come down and things keep getting pushed out, it just continues to be, you know, I think too easy for DTN to be pushed out, you know, down the road before it gets implemented. Okay, so.
Any questions?
I've just got a very brief comment, which is that the Space Mobile Network, another way of looking at the same structure is the Solar System Internet Green Book produced for CCSDS a couple of years ago, which talks about these kinds of peering relationships. So there is already some thought that's gone into this, and some endorsement from the international spaceflight community.
Great.
So first of all, I want to advocate for more beer on the space station. The second question has to do with the way in which the TDRSS assets are currently allocated. Is it possible to have a ground station, for example, which is not always in use but could be activated at need? This is sort of like being able to get in the queue. I'm thinking about the possibility of having some assets that are DTN capable that could be linked in to and make use of the TDRSS, either in its current form or in some future form, but not necessarily always activated. This would give us an opportunity, when the opportunity arises, to use it. For test purposes. I hope I didn't just spew virus all over the microphone. Yes, sorry about that.
Let's say, so for test purposes, there is the ability to, and this sort of made my living doing this for a while with since TDRSS is in geo orbit, so if you can get time on link, and you have the equipment, which at Goddard, you know, I've been able to have both at the same time, then we can do tests, you know, through the system and get it, you know, down completely through TDRSS. So you mentioned the South Pole. So in '97, I was the lead on the spitter, the South Pole TDRSS relay, and that was when I got into this whole networking thing. Right? So we put the then, you know, it was a big deal. We had megabit per second through TDRSS to the South Pole, which at the time was you know, much higher rate than most people were getting, you know, from their homes and elsewhere. And because from the TDRSS spacecraft point of view, so there was some equipment that was at the ground station at White Sands, and then some equipment was at the South Pole. So from the TDRSS spacecraft point of view, it didn't care whether it was pointing at the South Pole or pointing anywhere else. So so I followed that up with building a portable terminal that had that same as the South Pole side, so that we could demonstrate, and the TDRSS spacecraft was only in view of the South Pole for a few hours a day, so there was, you know, another 21 hours a day to be able to do demonstrations. So it took that portable terminal, and a megabit per second was a big deal then, so I got to go see some solar eclipses and some cool stuff until a megabit wasn't a big deal anymore. But then, and then that led to eventually a demonstration on the shuttle on the Columbia mission, where we did that. So right now, so there's still a South Pole TDRSS relay is still there, and they just upgraded the McMurdo TDRSS relay system. So I'll make sure that you get to see both of those when you're down there. And so we're looking to do some demonstrations and to do some DTN through those links. But we also have the ability, like they do at JSC as well, in places where you can test through TDRSS.
How do you guys keep somebody from improperly trying to access TDRSS? You know, what if somebody just builds a radio ground station and starts blasting away in the general vicinity of the TDRSS satellite?
The first part is just because you can see the TDRSS doesn't mean it's looking at you. So it's got some.
These are steerable.
Yeah. So there's
okay.
multiple access antennas that can see everything that are lower gain, but the high gain antennas are steerable. So that's sort of the first part. And then once the antenna is looking at you, if there's a lot of power coming up that's not the user that's supposed to be, then we have a pretty good idea where it's coming from.
Yeah, this is called ballistic anti-jamming.
And you can call some people up.
Oh, sorry. Yep.
Yeah.
So, hello? Oh, evidently not. So how do you go about getting buy-in for something like this? I assume this is something that would have to be government subsidized to even get off the ground.
So I'll tell you if I'm ever successful. We've been trying for a while. This is my first time bringing out the bar and grill analogy. So we'll see how that one goes. So it really has been a challenge because the longer it takes, then there's these like proprietary or system unique solutions get put into place. So then somebody will say, well, yeah, that would have been great, but we just spent all this money 2 years ago to put in this infrastructure that does the same function. So, come back in 20 years when we're upgrading the system. Right? So it's really great that the space shuttle or space station is being so proactive and putting it on board. I think that'll help with the visibility. But with the space station implementation, you're showing that and I would say to talk to the payload people about why this is good for them, to say that they can do their science at their own pace, generate the data, generate DTN bundles, and then when the link is available, then the data will show up for them, and they don't have to worry about managing that whole data transfer process. So we can start to get that mentality, out to the PIs, and then to see it from that side. And then what I'm trying to do because I spend my time working for SCAN on the infrastructure side, is to help to make that case that DTN will allow us to meet the current user requirements, actually enable new things, and at the same time gives us this means to start with a lower cost infrastructure and build it out so it actually works out for everybody.
You're kind of thinking like a twofold system, a grassroots effort with implementations that are already happening, and then internally trying to push it and the new systems coming online and just gradually grow.
Yes, but I do think that the demonstrations are now going operational is really key to it. You're getting that experience and getting it out to people that aren't just the innovators. So Don showed that chart of the crossing the chasm chart. So I've talked about writing a little paper about the NASA crossing the chasm, where there's actually a bigger chasm on the left-hand side between the innovators and the early adopters. Is like a Grand Canyon there, right? So that's really a big challenge.
So it seems to me that many of the problems we've got are actually administrative or cultural rather than technological, in that if there are multiple organisations that are disconnected, say multiple nations sending missions to Mars, they need to know that they've got a complete end-to-end comm solution sorted out and not necessarily be reliant on somebody else's infrastructure in the middle to connect the dots. So what we end up with at the moment is several devices from different administrations roaming around that aren't talking to each other, all with duplicated comms abilities needing to get back to the central point being Earth. Now at the moment, I as a mug punter citizen sitting somewhere on the planet with a DTN-enabled computer can't send packets routed through the space station. I imagine I'm going to need somebody's permission and a whole pile of organisation and paperwork to arrange for that to happen. there's a cultural thing where we need to set up this open access common user facility that any organisation that needs to be able to access it can know that they can rely on that infrastructure being there once it's built for them to use as well as everybody else. So it seems to me there's some administration, some cultural things about either not invented here or making this available to all users in a similar way as we have with the internet on Earth today, that goes well beyond the technology and the code in the nodes for making all that happen.
And so I would agree. I think it's and if we do go to the bar and grill later, you can get me talking about non-TRLs, the non-technical readiness level issues that are actually, I think, the greater barriers than the technology thing. There's lots of cultural things, risk aversion and the like that really makes it difficult.
So just to speak a little bit, you're as a regular user out on the internet, it's unlikely that you're ever going to be sending anything across pretty much any space link, without a whole pile of paperwork. In terms of providing the kinds of cross support to, say, the various space agencies, that is exactly what this Consultative Committee for Space Data Systems is trying to do, right? And they started out life 20 years ago really looking at link layer compatibility and what do you want to do for modulation and coding, and they've moved up the stack somewhat to how do you do cross support of one agency's ground station from another. There's a whole suite of stuff that's involved in that, and DTN is a part of that I'm going to be talking about in a little bit. So the various agencies are all over that as far as understanding what those capabilities are and developing.
Ping pong.
So I guess to put that in terms of the bar and grill, you're saying that we really are getting to a situation where as long as you front up to the bar and get the username and password for the space-enabled Wi-Fi and agree to sign the user acceptance form to say that you'll use it properly, that it really is becoming a multiple user facility that multiple disconnected organisations can use that common infrastructure.
And you saw that a little bit in the discussion of Trek, right? They're looking at pushing at least on the payload side, if there's a little bit less paperwork if you're a payload operator on station, and they're looking at pushing the DTN capability all the way out to scientists there.
Yeah, and so there are, like the meetings I was at last week, there are this interagency operational advisory group, IOAG, which is the multiple countries sort of agreeing on how we're going to interoperate. There was a Space Internetworking Study Group team that some of us were on, which kind of laid out that in the future we're going to interoperate at the network level, but the difficulty is that it's always in the future, right? It's always going to be, the way it's going to be in 20 years. So that's the problem. Right.
So I believe we have a DTN experimental network. Isn't that correct, that you can VPN into? And I believe that also the scan test bed that I talked about, the experimental facility on station that's not connected to the operational folks, is much more accessible to do experiments, and that may be an avenue to approach as well. Remember that we're doing something with KNES. So I think there are opportunities to do it where the paperwork's less because there's no risk, minimal risk.
Any more questions? Okay.
All right. Good.